x2, x1 and x2 in I with x1 less than x2, we have f of x1 less than f of x2. So increasing, what do they mean by this thing is, so suppose this is my function here. Suppose this is my function here. I explain the definition here. So my function looks something like this. Okay, I say my function looks like this. What they are saying is they are picking up any interval. So if I say this point is 0, -4, 0, this becomes, okay, -3, I can say -2, this thing becomes -1, 0, this suppose I say is 0, 4, this I say is 1, 0, and this I say is 2, -2, and this becomes 3, 0. Suppose this is my question here. I made this question myself here. I say I'm taking any interval I want. I pick up any interval. Interval means I'm picking any part of the x-axis. I say I'm picking it from here, -infinity. First I'm talking about -infinity to, I say, -3. I'm talking about -infinity to -3. I pick up any interval. How do I check whether this interval is increasing, decreasing, or constant? How do I check? How do I check with this thing is, I pick up any 2 points I want. I pick up any 2 points I want. I pick up what's between -5 and -infinity and -3. They are saying I pick up any points. I say I pick up -4 and I pick up -5. They both are between this interval. Which one is bigger and which one is smaller? Is -4 bigger or -5 bigger?
-4 is bigger.
-4 is bigger than -5. I know it's, see, because -5 is this way, it's closer to this thing, so it's smaller, and -4 is closer to 0, so it's bigger. What they are saying is, put these values in your functions. What's the value at -5 and what's the value at -4? At -4 my fx is, what is my y value at? 0. Suppose it's -5, it's gonna be what? Let's see. Okay, I picked up the wrong one. Okay, so at -5 it's gonna be here, and -5 is gonna be here. My value is gonna be somewhere here for y-axis. It's gonna be something like -5, 4. My y value will be 4. Is my 4 less than 0? Is my 4 less than 0?
No.
No, it's not. It's not true. It's not true. That means it's not increasing. It's not increasing. For increasing, it will always be this sign. This will always be true. This will always be true. But you know what happens? What happens when you're choosing point like this? Okay, if this is confusing you, see the next definition. Let's see. First note down all the definitions. Let's see, and then I'm gonna explain. Note down this definition. I'm gonna explain that point again. Note down the decreasing definition and the constant definition. Increasing I already gave you, decreasing and constant. Note them. Guys, turn on your videos. I want to see your video on. Is anyone still noting down the...
For the constant definition, it's the fx equal is fx squared, or is it just be fx is equal to fx?
Fx is equal to fx.
There's no fx squared for constant.
No, fx just remains the same.
Okay.
Fx is basically, don't get confused with y. So basically if they say x1, x2, they mean here y1, y2. By this thing they mean y1, y2 also. Fx1 is basically y1. So if fx1 confuses you, it's basically y1, if it's easy for you to remember that way. Do anyone wants me to explain these? It's basically what we were saying here. Remember this example we did? It's exactly the same. What they are doing is they are saying go from this left towards right. Start going from left to right. And check your y values, what happens. And check your y values, what happens. So we checked our y values. First we checked from this here to this here. What happens? 0 was less than -2. Oh, sorry, 0 was greater than -2. What happens when my 0 is greater than -2? It's a decreasing function. Let's check the other from here. -2 to 0. -2 is less than 0. If these are less, it is increasing. Let's check from this to here. 0 to 4. My 0 is less than 4. 0 less than 4. It is again increasing. What happens from here to here? 4, 4. It remains exactly the same. So it's a constant. And then they check from here to here. The value is 4 and 1. 4 is greater than 1. 4 is greater than 1. It is decreasing. So basically what they are doing is they are going from left towards right and they are checking the y values. Are they seeing from left to right? Are they greater? If they are greater, it is decreasing. If it's less, it's increasing. If it remains the same, it is constant. That's what the definition says. Anyone who didn't understand the definition here? Okay. Next thing we're gonna move is, okay. Do you want me to do one more example on increasing, decreasing, or you guys got it? Okay. Let's go to next point I'm gonna go to is, okay, let's see here. I'm gonna write here is local maxima, local maximum, maximum and local minimum. We are talking about local maximum and local minimum. So you basically, in easy words, rather than making it complicated, if I have to put it in easy words, local maximum at C. I'm putting in, your definitions are in the book. You can always check in the book, but I am just putting it in easy language so that you understand it. Local maximum at C. This C will always come from x-axis. Remember, the C will always come from x-axis. Local maximum at C. You can say is a point from where my function changes from minimum from decreasing to increasing. So basically you can say local maximum at C, and this C will come from x-axis, remember, okay, is a point from where my function changes from decreasing to increasing. So the point from where my function is first is decreasing and then it's going to increasing, that will be the point of my maximum. So it should, can you correct it? Sorry, it's going to be increasing to decreasing. I'm sorry, it's going to be increasing to decreasing. I'm sorry, can you change it? It's going to be increasing to decreasing. Let me explain this. So here, okay, we had a previous example. Let me write minimum definition also and then I'll explain this point here. And then local minimum at C, this also will come from x-axis, is a point from where my function changes from decreasing to increasing. Okay, so how do I explain in words this thing? Let's see, these are in words. Let me give you an example. So copy this here. Let me copy this and I'll explain. Once you're done, let me take an example here. Let's see here. The same example we were doing before. Okay, here. So, what's happening? Let's see here. From 0 to this thing, from this point to this point, what's happening? What's happening to my function? Can anyone tell me what's happening to my function?
You're decreasing.
It's decreasing. And from this point to this point, what's happening?
Is there a minimum?
It is increasing, right?
Oh.
It's increasing. See, it's -2 to 0. It's increasing. From this point to this point, it's decreasing, and this point to this point, it's increasing. So it's going from decreasing to increasing. When it goes from decreasing to increasing, what happens? You have local minimum at what point? This point. And you will consider just the x value, -4. So in this case, local minimum will be at -4. And what's the value of the local minimum? And the value of the local minimum will be your y value, which is -2. Did you understand or no? Okay, let's see one more example here. I'm gonna do this example here. Okay, let's see. I have to find all the local minima and maxima points. Local minima and maxima points. How do I do it? Can everyone see this example? Okay. So let's see from here to here, what's happening? From this side to this side, what's happening? Can I talk to Shaira?
Yes.
Okay, Shaira. What's happening from -infinity to this point I'm coming here?
It's decreasing.
It's decreasing. What's happening from this to this? Just after that, what's happening?
Increasing.
So what happens when it's from decreasing to increasing? It has
Local minimum.
local minimum. Local minimum. You're correct. At what point? At what point?
What do you mean?
Local minimum will be at what point? What is this point? What is this coordinate?
Wait, sorry, where are you pointing?
Here. This one. So you're checking this thing. This thing is decreasing here and then it's increasing, right? So after this point, it's increasing, right? It was decreasing till here and then it started increasing after that, right?
Oh, I see. Mm-hmm.
So this point will be my local minimum.
Yes.
So what's my local minimum is at what point?
Negative 1, 1.
Just -1. You see just the x-axis.
Oh, I see. Just.
So my local minimum will be at -1. And the next part, if it says, what is the value? What is the value at the local minimum? What's the value at the local minimum?
1.
Yes, then you say the y-axis. Local minimum will be at your x-axis, and what will be the value at the local minimum will be your y-axis. So this comes from x-axis, and this comes from y-axis. Was
Yes.
okay. So we went from here. She said it's going decreasing till here, and then it's increasing. Okay, what's happening? This is increasing, and then it is, what is happening here?
Decreasing.
Decreasing. What happens when you go from increasing to decreasing?
You can find the local max
Yeah, local max. You're saying you're finding local max. Local max will be at what point?
at 1,
And what will be the value?
at 2.
Yes. So the value will be 2, but your local max will be at 1. Okay. Was Karen?
Yeah.
Okay. Can you tell me, is there any other local maximum or minimum there?
What?
Is there any other local maximum or minimum there in this graph?
A minimum?
There. See,
3?
yes, it is. So what's happening? Is it maximum or minimum? Let's see on the left side what's happening.
Decreasing.
And then,
Increasing.
so when it's decreasing to increasing, what is it?
A minimum.
Minimum. Local minimum. At what point?
3.
And what's the value?
0.
Perfect. You got it. Any doubt with this part? So I want everyone to do this problem. I'll give you a problem. Okay. I want everyone to do 33rd question. Do the 33rd question.
What number?
33. Number 33. Number 33. Alex? Alex is not here. Axel?
Yes.
Okay, Axel, you're gonna tell me, okay?
All right.
First part, you tell me what happens.
Excuse me.
For the first part, what do you see? Let's see, start from left to right. Okay?
Yes.
So what's happening?
It goes down, then up,
So what's happened? It's decreasing and then increasing.
increasing on the y-axis, all the way until the y-axis.
Yeah. So
Decreases back.
so what do you have? You have local maximum or minimum?
Minimum
Okay, local minimum at what point?
at -2.
Minimum at, you are saying, is -2. And what's the value?
0.
So you are saying f of -2 is 0. So the value is, this is the value, is 0 as well. Okay.
Could there be two local minimums?
Yes.
Since they're the same.
Yes.
All right.
Local minimum, that can be 2, 3, 5, no matter how many, yes.
All right. So the other local minimum is 2.
Yes.
The
Local
same value.
minimum you are saying is at 2. And what's the value?
The same value, 0.
Okay. Do you see any maximum?
Local maximum, no?
Yep. Can you see local maximum anywhere?
Yes.
At?
X equals 0.
Yes, at 0. And what's the
And
value?
then white 3.
Perfect. You got it. You got it. Anyone has any doubt how to find maximum, local maximum and local minimum?
When we write it the other way, saying local minimum at negative 2 0 or something like that, 2 0.
No, you don't write the negative 2 0. You just write negative 2, and if they ask you, see the question, if you see here, if you see the question here.
I mean, yeah, I see it. Just that so wouldn't it be easier to understand if we just put in like the 0.20 instead of just 2 value 0?
No, you cannot write like that, because local minimum is not at 2 0. Local minimum is at just 2. And what's the value at that point? It is 0. So if the question says you find just the local minimum, you don't even have to write the value. You just say the local minimum is at 2, local minimum at 0, local minimum at negative 2. That's it. That's your answer. But see, in this question here, if you read here, this part here, what are the local maximum values? They are asking you for the values also. That's why we are writing it. Did you get it? Is it clear or no? Was that your question?
Yeah.
Okay, perfect. Okay. So next thing we are going to do is, if you're clear with this part, is, let's see, we did that, local maximum, local minimum. Next thing we're going to come to absolute. So that's easy. That's easy. Absolute. Next thing we're going to talk about is so we're going to write absolute maximum, absolute minimum. So what is absolute maximum, absolute minimum is? So absolute maximum, let's talk about. So basically you can say absolute maximum will be the highest local maximum, and absolute minimum will be lowest local minimum. So absolute max is the whatever is the highest one, that will be my absolute one. The highest local minimum maximum will be my absolute maximum, and the lowest local minimum will be my absolute minimum. Example. Let's see these examples here. Okay, let's see these examples. Okay. Can I have Jelena? Carly?
Yes.
Yeah. So can you tell me in the first one here, let's talk about local maximum and local minimum. Local max and local minimum. What are the points of local max here?
Is that a 3?
Yes.
3, 6?
Yeah, so the local maximum will be at
3.
okay. And is there any other local max?
No.
No. Okay. What about local minimum?
4.
Is there any other local minimum?
No.
No. So in this case, it's directly, since there are only one of them, so these will be your absolute maximum and absolute minimum also.
Okay.
Okay, can you help me with the next example also?
Yeah.
Okay, let's see. Let's see. So what's my local max?
Um.
Actually, you know what? They're considering these points also as local maximum or minimum.
Oh, okay.
They're considering. So in this case, let's see. What's your local minimum? So, wait. They're considering this also. Let me check it. No. They're not considering that. Yep, they are considering these also. So since this point, you will be like, oh, I don't know what is that side. But they are considering this also.
Okay.
Okay, so in this case, let's see. I'm sorry, can you change this part here? Erase this part here. Okay. Some books don't consider that, but here it's okay. Yeah. So let's see, what are my local maximums like? Let's talk about the first one. What are my local maximums?
It would be 3 still,
And?
and 5.
Yes. And what about local minimum?
0 and 4.
0 and 4. Okay. So for local maximum, if I need to find absolute maximum.
It would be 5.
No. See the highest one.
Oh,
Is
3.
this bigger? This is, more right. This has more
Yeah.
value than this. So it will be 3.
3. Okay.
What about absolute minimum?
0.
Yes, 0. Perfect. And what's the value? What's the value at absolute maximum?
6.
And what's the value in minimum?
1.
Perfect. You got it. Did everyone get this or no? So they are considering these also at maximum and minimum. Okay. Can I have Hawkins? Hawking?
Yes, I'm here. Sorry, I needed to unmute my microphone. I
It's
just spilled some coffee. I had to clean it up. I apologize.
No, it's okay. No problem.
Okay, where are we at?
Can you tell me what are
Um,
the second? We are doing the second problem. Can you tell me the maximum ones? Local maximum is at what point?
And of the second example?
Yes, second example.
Okay. 1,
1 and?
5,
Yes, perfect. And what's the values?
2 and 3, respectively.
Okay, and minimums?
3
3
with a
and?
value of 1.
Okay, with the value of 1. Okay, perfect. So what's my absolute maximum?
5,
Yes, and what's the value?
3.
Why did you choose 5 and not 1?
Because it's the y
Yes.
value is higher.
Yes, perfect. Because my y value is higher than this y value. So that's why I'm choosing
Yeah.
my absolute as this thing. What about absolute minimum?
Okay, 3 and a value of 1.
Minimum, yeah. 3 at value 1. Any doubt here? Anyone? Okay. Can I have Jelena? Jelena is not there. Can I have Giselle? Giselle? Giselle is not here?
Yes, we're here. Sorry.
Okay. Can you tell me the third one?
Yes, I'm still kind of confused.
Okay.
I'm kind of confused in when it's decreasing.
So what happens here? So decreasing, when you have to check decreasing or increasing, what you do is look at the y values. Let's look at this example. Let's look at the y values. What's the y value here at this point?
Sorry. I have it zoomed in. There we go. On which one? What problem would it be?
First one I'm talking about.
The first one. Okay. It would be 1.
And what about the next one? What's the y value?
It would be, I believe it's a 6.
Yes, it is 6.
Okay.
So what's happening? Is my y values increasing or decreasing?
It's increasing
So it's an increasing function.
and then decreasing,
Yes, and then
increasing.
perfect, you got it.
Okay.
And
Thank you.
so this point will be my what? Minimum or maximum?
Maximum?
Minimum, because it's going from see, it's not coming, usually it's like this, right? It's coming from
Okay.
decreasing to increasing. It's going to increasing, right?
Yeah.
So it's
Oh, but it says it's minimum.
Yeah. What about this one? It's going from increasing to decreasing. This is maximum.
Maximum.
This is
Minimum?
minimum.
Maximum.
Minimum.
Okay.
And this is maximum.
Okay.
Remember, up of the hill is maximum. Up of the hill are always maximum. And the highest
Okay.
hill will be absolute maximum.
Okay.
And the lowest one
Up the
here
hill.
is minimums. And the lowest value, the lowest of all of them will be the absolute minimum.
Okay.
Did you get it?
Okay. Yes.
Okay, I want
Thank you.
everyone to do the next 3 parts. I want everyone to try C, D, and E part right now. Okay, so can I have Jesse, Ben, Eduardo?
Yeah.
Yeah, can you tell me the maximum, local maximums?
The local maximum is going to be around. It's going to be at 2.1 to 5.4, which means it's going to be decreasing to increasing, right?
So no. First, at what points are my local max?
It's going to be. Let me check here. Is it going to be 5 value 4, right?
No, just the x-axis, just x values. I'm not talking about y values. So local max will be at
5.
and is there any other max?
No.
See, it's this also on the top of the hill.
Yeah, I mean, that's 0.
Yes.
Just sorry. Just I got a bit confused on the constant version on the bottom.
Okay. What's the value at 5?
Value 4.
And what about 0?
Value 3.
3. So these are my values. So what's my absolute? Absolute maximum.
Your absolute maximum is going to be at 5.
Yes, 5, 4.
Value 4.
What about local minimum? Can you tell me local minimum?
I would say 1.
Mm-hmm.
Value 1. Just at are you supposed to choose between the 2 or the 2.1 or the 1.1?
It is 1 and 2 both. See, it has both points, right? At this point also, at this point also. They both are at the bottom, right? They're the minimum values. It's
Yeah.
both of them. And the value is 1 and 1.
So we just only go to the one that's first on minimum, right?
Yes, so which one do you think is?
So we're just choosing 1.1 then.
So it's, the thing is, what it's gonna be at 1 1. I'm not saying you have to choose. It's not just, see, the one values in this whole interval, right? This whole interval is constant, right?
Yes.
So my absolute maximum will be in the whole interval. It will be in the whole interval from 1 to 2 because it's a constant value. Are you getting my point?
Yeah.
It's absolute minimum.
Oh, it's, yeah, sorry, it's absolute minimum, correct. You know, one thing, it's like, rather than writing like local, okay, I'll explain this later. Okay, let's do the this example. Let's do this example. D part, can I have Karen?
Yeah.
Can you tell me what's the local maximum for that one and local minimum?
Sorry?
Can you tell me local max and local minimum?
The D?
Yes.
A minimum 0,
0. And what's the value?
0.
Okay. So my absolute, there's just only one minimum. So my absolute minimum is 0. Okay. What about local maximum?
Infinity?
Yep. There isn't any because you don't know, right? You don't know. It just keeps on going. So there is no absolute maximum.
No.
There's no absolute maximum. Okay. Let's see. Okay. This is nice. Okay. Can I have was?
Yes.
Can you tell me the last one?
What name?
Can you tell me this one?
Okay.
Local maximum.
Local minimum, right?
Well, let's see. Local max. What are local max points?
Local max will be 1 and 4.
Okay.
The value will be 4 and 3.
Local minimum you are saying is, values is you are saying is 4 and 3. And what's local
Yes.
minimum?
The local minimum will be 3 and 2. 3. Then the value will be 2.
You're saying local minimum is
Me?
what? So local minimum is the down of the hill. It is 2 2, right?
Oh, 2 2. Sorry.
Yeah. Can you see in this example? Can you see, if you can see? I don't know. It's not clear that it's an open circle. Do you see the circle is not colored?
Yeah.
That means these points are not included.
Oh.
So this point is not even there. Even 2 2 is not colored. So even this point is not there.
Okay.
So only this thing is the point local maximum, right? Since there is only one local maximum, that will be my absolute max also.
Oh.
And there is no local minimum.
Mm-hmm.
Minimum.
Mm-hmm.
Did you get my point? So if there is, note everyone here, if there is open circles, those points are not included. Colored circles, those points are included. If it's open circles, those points will not be considered as maximum or minimum because they're not even part of the graph. They're not even part of the graph. Any doubt with maximum or minimum? Okay, I want to specify one thing is, in this I wrote accidentally this local maximum minimum, but I want to clarify this thing. Whenever you're talking about local maximum, local minimum, whenever you're talking about local maximum, local minimum, just a second. Nikhil, can you get me pen?
Yeah.
Whenever you're talking about local maximum and local minimum, it's always shows local maximum will always go from, you will consider points which were going from increasing to decreasing only. Okay, and this thing will always be from decreasing to increasing. somehow in previous example when we were talking about, you know, these things, absolute maximum, you know, we were in this example, let's take in this example, I wrote this as, you know, local maximum, local minimum. Okay, when I was finding, you said local maximum was at 3 and 5. 3 and 5. Yes, because it's going from increasing to decreasing. Perfect. 3 is my point. But 5, if you see, it's going only to increasing. After that, it's not decreasing. So this, I mean, technically for absolute value, you will be writing like this. But technically, if I just say you find local, then this thing is not even a local maximum point. Are you getting, oh, it's confusing. I confused you by writing this local maximum, local minimum. I should have not written that. Wait, I explain. Whenever you find absolute value, I would suggest you not to write local maximum. Just write maximum minimum, because local is different. Local is different. If you understand that part. Whenever you're finding absolute max or minimum, find the max. Max here you said is at 3 and 5, and minimum is at 0 and 4, and then find the highest one. The highest one is 5, you know, absolute is 3 and value is 6. The way we were doing. Don't write local. Don't write local. Did this confuse you? Okay, let me explain again. I'll explain this again here. Let's do, I'm gonna do this example again, the first one here. Okay, so the question says I need to find here absolute maximum and minimum, and I need to find local maximum and minimum also. I need to find these 4 things now they're asking me. Okay, so let's talk about local maximum and minimum. Local maximum and local minimum. What is local maximum? It goes from increasing to decreasing. Here it's going to increasing to decreasing. 3 is a point and the value is 6. Okay, what about the next point? Here you are saying this thing is local maximum. This is not local maximum. Why? It is going to increasing, but do I see decreasing? No, it's not decreasing after that. I don't know what it's doing after that. So it's not my local maximum. But let's see local minimum now. Here, you are saying this is point of my local minimum. Why? Do you know that it is decreasing from here? Is it showing you? No, it's just increasing showing you. So it's not a point of minimum. But let's see this point. It's decreasing then increasing. So I definitely know this is my point of minimum. And the value is 4. So I'm done with local maximum and local minimum. Now let's talk about absolute. Now I'm going to talk about absolute. Let's see maximum values and then minimum values. Maximum values are which? Top of it's this thing. 3. From here it's going to here. So you're going to consider 3 and the value is 6. Then you will consider this also. When finding absolute, I'm not talking about local right now. I'm just talking about maximum. And what is the maximum value? This thing also, the end of the graph, this is also my maximum value. Its value is 5 and you know, it is at 5 and the value is 5. And then the absolute one will be the highest one, highest value. So absolute max will be at 3. Similarly, minimum. Okay, one minimum, this will definitely be one of my minimum, 4, 4. But this will also be my minimum in this case. Because this is the end of the thing. So it will be at 0, the value is 1. And whichever is the minimum one, it's this thing, that will be absolute minimum. So it will be at 0. And the value will be at 1. Are you getting my point or no?
So X is the max or minimum and Y is the value?
Yes, Y is the value. Yes. Y is always a value and this point will always be my X. My point I'm only trying to explain is when you consider local maximum and local minimum, you have to see from increasing to decreasing or decreasing to increasing. This is not my local maximum or local minimum because I don't see this side of the point. But when you are considering absolute maximum or absolute minimum, you have to consider the end points also. You have to consider the endpoints also. That's what I'm trying to say. Any doubt with this thing today? So today I'm going to end it here. From section 2.3, I'm just left with one thing, which is averages, which I'm going to do in the next session tomorrow. If you have any doubt, you can stay. Other than that, I have already taken the attendance. Homework is already assigned, so make sure you start doing your homework. Thanks, guys. Have a nice day. If you want to stay, you can stay for the office hours. Thanks, guys.
Have a good day.
Have a good day.
Have a nice day.
So,
Is Kate?
Yeah.
have a good day.
Just a second. Like, some are leaving, and then we can talk. Yes. Okay. Let's see. Jose. Yeah.
Mrs. K, Daniel Marone asked me to tell you that his microphone is not working.
Who?
Daniel Marone.
Okay. I'm marked him present. Yes, I saw his message. Yeah. Perfect.
Okay.
So thanks. Anybody else?
So you're not assigning today's homework?
I'm gonna sign right now after this.
Okay, thank you.
Yeah.
Have a good one.
You too. Have a nice day. Take care.
I think we were talking earlier about my math lab.
Yes, Angel.
Yeah. So you're saying call tech support on my Pearson?
Yes, call tech support on Pearson. Tell them what you are facing, the problem, what happened, and they're gonna help you out with that. Until that time, you're gonna get a temporary access.
Okay.
Okay, so just on Google, if you say, how can I get temporary access to my math lab, they'll give you the stepwise how to do it.
Okay, so I'm gonna have to redo the homework on the new account?
Yes.
Okay.
Yes. No, wait. You are in my class?
Yeah, I'm logged in. I'm able to go in. It's just that the name.
Okay, it's okay. So what name are you? What's your name?
My name is.
No, on my lab.
Oh, the name is Caesar Amador.
So can you email me that? The name of my lab?
Okay.
So I'll know it's you. You don't have to change anything. Keep on doing in that then.
Okay.
Yeah, perfect.
Yeah, I did change the username to my name. But the original name on there is Caesar Amador.
You are in my class, right? You sure?
Yeah.
Okay. Perfect.
Are you able to see if there's any students under like Caesar Amador?
I'm gonna check. Can you wait? Let me just talk to them and then I'll help you. Okay?
Okay.
Eduardo. Yes.
I'm part of DSS and I'm supposed to send you an accommodation forms for all the quizzes and tests that we're going to be taking.
Okay.
And to have an extended time for quizzes.
Yeah. So you can send me the form. I'll sign it and I'll send you back. Okay?
Via Canvas.
Oh, you sent it me through Canvas?
Yeah. Or you want the email?
Can you send me through email?
Yeah, I'll gladly do that.
Yeah, perfect. And then I just have to sign it and send it to you, right?
He can, but I just have to give it to you just for you to ensure that you have someone from DSS that need extended time for tests and quizzes.
Okay, perfect. So I'll make note of that and then, yep, perfect. So just during the exams, can you let me know beforehand, hey, I'm DSS, can you extend the time for me?
Yeah.
Perfect, Eduardo. Thank you so much. Yes. Christopher?
Yeah, I just need help with last week's lesson. Yesterday's lesson, not last week.
Okay, so, okay. Can I just help? Okay, first, tell me, what was the problem?
Oh, no, it's on the homework.
Oh, it's on the homework, yes. Can you tell me? What was the problem?
So the problem is root 19 over x plus 3, but it's like the roots over the whole thing.
Root 19 over x plus 3. Okay. So what's the question asking you? What they want you to do?
It's just find the domain.
Finds the domain. Okay. So basically you can write it like this. You can separate the square root like this also.
Okay.
So in the numerator, square root of 19 is just a constant number. I don't care about that thing, right? But we have a square root in the denominator. So whenever you have square root in the denominator, what do you do?
It's less than 0.
Greater than 0. Greater than 0. Strictly
Oh, yeah, greater.
Greater than 0. Then solve. What do you get?
So you subtract 3 to both sides and get x is greater than -3.
So let's see. My -3 is here. Negative infinity is here. Infinity is here. What are the numbers greater than -3? What are the numbers greater than -3?
It's to infinity.
Yeah, to infinity. So my number line, what will be my domain?
So it would be bracket -3 comma infinity parentheses.
What kind of, will I put this bracket, first one or second one?
First one.
Yeah, perfect, because this is not included, right? Perfect, you got it. Any other doubt, Chris?
Is that it?
Yes, that's it. That's your answer.
Oof. Okay.
Yeah. Yeah.
I guess that should be fine for now.
Just let me know if you have more questions. You can always come a little bit early. I can help you out. You know, I'm usually here 15-20 minutes early also, okay?
Okay.
Okay, perfect.
Thank you.
Yeah, take care. Bye.
See ya.
See you. Yes, Angel. Let me check, okay? Can you wait? Can you let me check, okay?